Here in this video, we are going to demonstrate an example of number 27 in assignment C. Hypothesis testing is a chi-square test for variation. Also in the Google Classroom TR6E2WI, please note that you can obtain a lot of videos with regards to assignment A, B, and C. We're on C at the moment. So the topic here for this scenario is tourist arrivals. And the research question is there a change of arrivals from 2021 to 2022? And the hypothesis, which is a response to the research question, because the question is asking, is there a change? So then you can possibly respond by saying there is a change from 21 to 2022. You can say there is, or you can say there is not. So this hypothesis chooses to say that there is a change. So the objective is to determine if there is a change of arrival from 2021 to 2022. Now, as we see, this is an example of number 27 in assignment C. So here's number 27 in assignment C. And you've got to complete the topic, the research question, the objective, like the example. And here are the values that were collected. That's the data that were collected according to number 27. But the data collected according to the example, here it is. And we are going to take a critical value approach. And in the critical value, which is 9.348, sorry. Now, the first step in the chi-square test is to state a pair of hypotheses after you have identified the appropriate chi-square test. You can get these steps in the file labeled Research Project and Hypothesis Testing, Critical Value or Classical Approach for chi-square test. So the first step is to identify the chi-square, which is a chi-square test for variation in this case. And the second step is to state a pair of hypotheses, the null and the alternative. We normally consider the null and the alternative like two persons debating. Okay, so according to the chi-square test for variation or goodness of fit test, the null will be saying that the observed values are equal to the expected. So that means that's implying that there is no change. So the null is saying no change. And the alternative null is saying, no. The observed values, what I'm observing is not equal to what I'm expecting. Okay, so that there is a change. So two persons debating, who win? You need a rule because you need a third person to use a particular rule to determine who wins. Okay, now the rule is that you have to sketch a distribution curve, which is a right tail curve for the chi-square, skewed to the right. You need to shade a critical region, which is on the right, and to place a critical value on the critical point. So this is the rule that the third person, which is the test statistic. So the test statistic is like the referee, the test statistic is like the judge that is going to use that rule to decide whether or not to nullify the null. Okay, so after you place the test statistics on the distribution curve, then the test statistics will either tell you to reject the null or to nullify the null or do not reject the null. So the two persons that are debating the null and the alternative. So the null is in anticipation of what the test statistic is going to say about it. Okay, will I be rejected or will I not be rejected? Okay, so if the null is rejected, then the alternative has won the debate. Here it is. If the null is rejected, then the alternative is the conclusion. If the null is not rejected, then the null will say, yay, so I'm the conclusion. Okay, so here this was demonstrated using this example. Here is a pair of hypotheses, the two of them. The observed values are equal to the expected values, no change according to the null, and the alternative is saying the observed values are not equal to the expected values, that there is change. Now here's the rule. The distribution curve skewed to the right, the critical region is on the right, the critical value on the critical point. And as you know, here is to be said, reject the null. HO is the symbol for the null. And here is to be said, do not reject the null. The HO is the symbol for the null. Okay, the non-rejection, the unshaded, the rejection region, the shaded region. So now, to calculate the test statistic, you have to use this formula, the sum of O minus E all squared divided by E. Now, here now we have got two sets of values. The expected values is what transpired historically. That's what you expect to happen. But the observed values now is what you're observing right now. So you're going to compare what you're observing now with what you expected. Here we're going to perform this, the calculation of these test statistics, because we have to use tables. Once you use sigma, you must think of tables before, because you have to do some calculations before you add up, before you sum up. You normally sum up last. Each calculation is called a chi-square contribution. So here we have listed the O's, and here we have listed the E's, and here we perform the O minus E all squared divided by E 4 times. These are the 4 chi-square contributions, and when they were added, will give us the chi-square test statistic. Now I'm going to demonstrate how this can be quickly done using Excel, because I repeat, whenever you see sigma, you have to think of a table, because you've got to do some stuff before you add. Okay, here is 4 of them you've got to do. Now, whenever you think of table, you can easily think of Excel or Google Sheets. Here, this was already done for a previous example. So the observed values, we can list them in column A, 520, 610, 750, and 1005. And the expected values will be 500. Now, as you can see, because the formula has been programmed already in this spreadsheet, the calculations for each chi-square contribution is being calculated automatically, and the summation is being done automatically. 640, 750, and 1007. And here we've got our chi-square. Oh, this is 1008, not 1005, because I can see there's a slight discrepancy because we got 3.36. So this is 1008. So there's another discrepancy. Oh, that's 780, not 750. Right, so here it is. Okay, if you click on column C, you will see the formula equal A1 minus B1, because the first observed is in A1 and the first expected is in B1, divided by B1, that's the first expected. O minus E all squared divided by E. And when you can easily drag the formula and it will automatically calculate all the chi-square contributions. And here we've got the sum function, the sum from C1 to C4. Now we've calculated the chi-square test statistic, which is like the referee. Now it has to go and make a decision. It has to go and speak. It has to say either to reject the null or not. Now it depends on where it lands. 0 and 9.348 is already on the number line, are already on the number line. So we got to place 3.36 in an appropriate region. Is it between 0 and 9.348, or is it after 9.348? Clearly, 3.36 is less than 9.348. So it has to be between 0, anywhere between 0 and 9.348 suffice. So we can clearly see that the test statistics is telling us do not reject the null. So that is what we've got to conclude. Decision, since the chi-square test statistics 3.36 is not in the critical region, the null, which is HO, is not rejected. So since the null is not rejected, it will be the conclusion. So here, the conclusion is, since the null was not rejected, it is the conclusion. Hence, based on the data, because it's always good to start by saying based on the data. Another person who has collected a different set of values can come up with a different decision, different conclusion, different test statistic. Okay, same setup, but different judge and different decision, different conclusion. So it's good to say, based on the data, the observed values are equal to the expected, hence there was no change in the tourist arrivals according to these values. So in summary, you've got a topic, a research question, hypothesis, objective. You've got to collect your data. Here we are comparing 2 different years, and you've got to set up the null and the alternative. The null will always be saying observer equal to the expected, no change for chi-square test, a goodness of fit test. And the alternative will always be saying that the observed values are not equal to the expected values, that there is a difference. Now, that is that the 2 persons debating. Now we've got to set up the rule, which is a right tail curve, and the critical region is placed on the right and the critical value on the critical point, because we're taking a critical value approach. Now we've got the rule set up, the do not reject zone and the rejection zone of the null. The rule is that either you reject or do not reject the null, or nullify or not to nullify the null statement. Now we've got to call the judge, the referee. We've got to calculate the test statistic using this formula. This is a sum formula, so therefore now we've got to calculate some values before we sum. Each value is called a chi-square contribution, O minus E all squared divided by E 4 times. And then when these were added, this will be the test statistic, or you can call it the judge or the referee. It's got to be placed on the number line on the distribution curve, and where it lands, it will tell us what to do with the null. So because 3.36 is less than 9.348 here, we do not reject the null. And that is the decision that was made. And since the null statement was not rejected, it will be the conclusion, which is stated here. So in a more concise summary, 2 persons are debating the null and the alternative. The null is the one to be nullified or not. The rule has to be set up, and then the judge or the referee has to be calculated, and the judge or the referee have to come and tell us either to reject or do not reject the null, either reject or do not reject HO. And then according to what was said, if HO was nullified, the alternative has won the debate. It will be the conclusion. And if the null was not nullified, it will be the conclusion.